In the previous lectures, we have been discussing about the various methods of allocating memory to processes, and we saw that there were problems that we faced during memory allocation, and the biggest problem that we faced and discussed was fragmentation. So under fragmentation, we discussed about external fragmentation and internal fragmentation, and we saw that external fragmentation was a big problem that we faced during memory allocation. So what happens in external fragmentation is that though we may have enough memory that can be allocated to a particular process, we were not able to do so because the memory fragments were not contiguous. So we are able to allocate memory to a particular process only if the fragments are contiguous. So that was the biggest problem that we faced. And we also tried to come up with some solutions for that, but we saw that those solutions were not so effective, and also they could not be used in many of the cases. So here in this lecture, we will be discussing a new topic that is called paging. So paging is a solution for external fragmentation. So we will see what is this paging and how it can be used for solving the external fragmentation. So here it says, paging is a memory management scheme that permits the physical address space of a process to be non-contiguous. So till now, we have seen that we are able to allocate memory to different processes only if the memory fragments are contiguous. But here, paging is a memory management scheme that permits us to allocate memory to processes even if the physical address space is non-contiguous. So what happens is, paging avoids a considerable problem of fitting memory chunks of varying sizes into the backing store. Most memory management schemes that we have discussed before suffered from this problem. So what is the problem? The problem was the one that I just talked about in the beginning of this lecture. So paging is going to allow us to avoid this problem. So let's see how that is done. So here we'll be discussing the basic method of paging. So we will see what are the basic methods that are applied in paging and how we are able to achieve the task of allocating even non-contiguous memory locations to processes. Alright, so let's see how it works. So first of all, what happens is, in paging, we break the physical memory into fixed blocks called frames. So the physical memory or the main memory that we have, it is broken into several fixed size blocks or partitions, and we call them as frames. And then we also break the logical memory into blocks of the same size called pages. So here, when I say logical memory, just think about it as the memory of the processes. So we are breaking the physical memory into fixed size blocks called frames, and the logical memory is also broken down into the same fixed size blocks, and we call them pages. So keep these terms in mind, these are very important. In case of logical memory or processes, the blocks are called pages, and for physical memory, it is called frames. And now, when a process is to be executed, its pages are loaded into any available memory frames from the backing store. So here, what we are going to do is, whenever we want a process to be executed, then the pages of that process, and what is pages? We just discussed here. The pages are the blocks of memory into which the process is divided. So these pages will be loaded into the frames. And what are frames? They are the blocks in the physical memory. So since they are of the same sizes, we know that one page will perfectly fit into one frame. So this is how it is done. The backing store is divided into fixed size blocks that are of the same size as the memory frames. So the backing store is the place where the processes are stored before they are executed. So even the backing store is divided into the same fixed size blocks so that we can store the processes in that format. So this is the basic idea of paging. So let's dive into it a little deeper and try to understand visually how paging works. So here we are having our physical memory. So this large rectangle here, it represents our physical memory or the main memory. So this is a memory that has to be allocated to the different processes. And here we are having 4 processes, process P1, P2, P3 and P4. So in a normal case, if it was not for paging, what we would do is we would just take the processes, and based on the scheduling algorithms that we have, we will just be loading them into the physical memory and they will begin their execution. But in case of paging, what we have to do, remember the first point, we have to divide the physical memory into frames and we have to divide the processes into pages. So let's do that. So here we have divided the physical memory into frames, and then we have divided the processes into pages. So for example, this is process P1 and we have divided it into 1, 2, 3, 4 pages. So this is the fixed size block into which we are dividing the process P1. And similarly, the physical memory is divided into frames. And keep in mind that the size of these pages and the size of these frames should be the same. So that is why we said fixed size blocks. Alright, so we do the same for all the processes. Process P2 is divided into its pages. So I'm calling it like PP2, so which stands for page of process P2. So this is the first page, second page, third page and fourth page. And here we have the pages divided for process P3 as well as for process P4. Okay, so the division part is complete. Now we have to load these into memory. So let's say that we are using the first come first serve scheduling algorithm here. And let's say the order in which these processes arrived was P1, P3, P2 and P4. So P1 was the first to arrive, then P3, then P2 and then P4. So if they have arrived in this order, how can we allocate the memory to them? Let's see. So here we have allocated the memory for all these processes. So if you see here, process P1 was the first to arrive. So all the pages of process P1, which is PP1, PP1, PP1 and PP1. So these 4 pages are allocated the first 4 frames of the physical memory. So we see that process P1 is stored here. And I said that process P3 was the next one to arrive. So we store all the pages of process P3 into the next 4 frames here. And then the next process to arrive after P3 is P2. So the 4 pages of P2 are now stored into these 4 frames of the physical memory. And similarly, process P4 was the last to arrive, so the pages of P4 are stored into these last 4 frames of the physical memory. So this is how the pages are allocated different frames in the physical memory. So this is the basic of paging. Now let's say that at some point of time, process P3 and P4 has completed their execution, and hence they have vacated these frames in the physical memory. So we see that P3 and P4 are now gone, and we have these many frames that are left empty now. So here there is a chunk of memory that is left empty. Here also there is a chunk of memory that is left empty. And remember that they are divided into these frames of fixed size. All right, now let's say that at some point of time, there is a new process that arrives, which is process P5. So P5 has now arrived, and we see that P5 is a bigger process. So it is having 8 pages, 1, 2, 3, 4, 5, 6, 7, and 8. So it is a bigger process, and it is divided into the same fixed size blocks. And when we divide it, we see that we are having 8 pages for process P5. Now we need to allocate memory for this process P5 for its execution. So in normal case, let's say that if we were not using paging, then what would happen? We will not be able to allocate memory for process P5. Why? Because we see that the empty space that we have in memory is here, and they are not contiguous. We see that the process P2 is there in between. So we see that this is a big process and it needs a bigger amount of space. So this process individually cannot fit here, and also it cannot individually fit here alone. So in a normal case, we would not be able to allocate this space for process P5, but we are using paging here. So in case of paging, we know that the memory is divided into frames and the process is divided into pages. And the most important concept of paging is that it allows allocation of memory even if the memory is not contiguous. So what we can do is we can allocate the first 4 pages of process P5 to the empty frames over here. We see that we have 4 empty frames here, and also the next 4 pages of P5 can be allocated to these empty frames over here at the end, because here also we have 4 free frames. So this is how the memory can be allocated now. So we see that the first 4 pages are allocated these 4 frames here, and the last 4 pages are allocated the last 4 frames here. So here we see this is the beauty of paging. We have solved the biggest problem that we had, which was external fragmentation. So we see that we are able to allocate memory even though it is not contiguous. All right, so this is the very basics of paging, of how it works and how it is able to solve the problem of external fragmentation. Now there are other things that we need to discuss, like how will the operating system know which pages are stored where in the physical memory? Because we see that since we are storing these pages into non-contiguous frames, we need to keep a record of which page is present in which frame. Otherwise, we will not be able to know where the processes are being loaded into. So we need to have some way in order to keep a record of that. So that we will be discussing in the next lecture. So I hope this lecture about the basics of paging was clear to you. Thank you for watching, and see you in the next one.